Good afternoon. I am Professor Vikash Sharma from Department of Psychiatric Nursing, Mahatma Gandhi Nursing College, Mahatma Gandhi University of Medical Sciences and Technology. Today I am going to shed some light on true experimental research designs. These are the true experimental research design where researcher has entire control over the extraneous variables and can predict confidently that the observed effect on the dependent variable is only due to manipulation of independent variable. As we all know about the extraneous variables, these are such variables which are not actually the part of the research study, but they are just outside of the research study and they can affect the research study. There are some essential characteristics of true experimental research design. There are three essential components of it, and these are randomization, control, and manipulation. Manipulation refers to conscious control of the independent variable by the researcher through treatment or intervention to observe its effect on the dependent variable. Here the researcher has conscious control of the independent variable and he just manipulates it just to see the effect of these variables on the dependent variable. Let's say if any component or any element which has effect on our health. So researcher has the capacity to manipulate here the independent variable just to see the effect of it on the dependent variable. In other words, it is a conscious act by the researcher where he or she varies independent variable and observes the effect that manipulation on the dependent variable of the interest. This manipulation characteristic is only found in true experimental research design. It cannot be found in non-experimental or other type of research studies. Let's say, for example, if a researcher is conducting a study on efficacy of chlorhexidine mouthwash on the prevention of ventilator-associated pneumonia among patients admitted in ICUs. So here, what researcher wants to do is, he just want to see the effect of chlorhexidine mouthwash, that is the independent variable in this study, and this will be manipulated in such a way that this mouthwash will be administered to the experimental group of the study, and the control group of the study will be given the routine treatment. They will not be given this chlorhexidine mouthwash, so that at the end of the study, the effect will be observed on both the experimental group and the control group, and definitely there will be some spatial effect of this treatment on the ventilator associated pneumonia of the experimental group. So this way researcher can manipulate the independent variable to observe the effect of it on dependent variable. Now the another characteristic of true experimental research design is control. It is an essential element of true experimental research design as it refers to use of control group. As we have already discussed that there are usually two groups in experimental studies, true experimental studies, control group and experimental group. So this control group is one of them. And the another meaning of control in true experimental research design is controlling the effect of extraneous variables on the dependent variable in which research is interested. So we have already discussed what are the extraneous variables which are actually not the part of the research study but still can affect the result of the study. And that's why a researcher who is willing to use true experimental research design for his research study, he wants to control the extraneous variables. And the subject in the control and experimental group are same in the number and characteristics usually. But the subject in the control group receive no intervention, whereas the intervention, special intervention or the independent variable will be used for experimental group of the research study, just to see the changes in effect of the treatment. The experimental group receives the planned treatment or intervention, and comparison is made at the end of the study with the control group, that what is the difference of result in experimental group and control group, to observe the effect of this treatment or intervention. Generally, in healthcare and nursing research, it is not ethically feasible to keep a control group deprived of interventions because it is considered quite unethical. However, existing conventional method of interventions may be compared with experimental interventions. So what is usually done in this type of research is to avoid this ethical problem, that conventional or traditional treatment which is given to the control group, and the spatial treatment or the independent variable which is planned to see the spatial effect, it is given to the experimental group only. Now, the third and important characteristic of true experimental research design is randomization. It means that every subject has an equal chance of being selected as a subject or sample in experimental or control group. So here there will not be any bias. All the samples or subjects have equal chance of being selected either to the experimental group or to the control group. Through random assignment of subject under experimental or control group, chances of systemic bias are eliminated. This is one of the great problems in conducting research, that there are some systemic bias, and it can be easily avoided by doing randomization. It is used in true experimental research design to minimize the threat of internal validity of the study and to eliminate the effect of extraneous variables on dependent variable. As we have already discussed, that it is the mandatory aspect to avoid the effect of extraneous variables in true experimental research designs. So randomization is one of the great way to avoid the effect of extraneous variables on the research study. Through randomization, on an average, the characteristics of the subject in experimental and control groups are similar. The number and characteristics of subjects in control and experimental groups are almost similar, and thus the influence of extraneous variables on dependent variable is eliminated by dispersing the validity of subject characteristics equally in both the groups. Now, there are certain methods of randomization through which the systemic bias can be eliminated from the true experimental research design. The first and very common method of randomization is flip of the coin. Now, what is usually done in this type of method? A researcher does the flip of coin for each subject, and if suppose head comes, the subject will be allocated to the experimental group, and if the tail comes, the subject will be allocated to the another group. So it depends upon the appearance of the flip of coin, that which subject will be allocated to which group, whether to the experimental group or to the control group. The another common method and very effective method is slip lottery method. Now, what is usually done in this type of method is, there are some piece of paper on which the name of the subject is written or the number of the subject is written, and they are put in one ball. And the way we take draw in the lottery method, a subject or the person blindfolded, he just pick up one of the piece of paper, and one after the other. It is the alternative choices, like the first piece of paper and the name of the subject written on that will be allocated to the experimental group, and the another one will be allocated to the another control group. The third one is random table. So there will be a random table prepared on which vertically and horizontally the number allotted or the code of the subject will be written, and a person who is blindfolded choose a number from the table of the number, either horizontally or vertically, till a requisite number is reached for both experimental and control groups. It may be used to facilitate randomization process. In this method, computer-assisted random sequences also may be used for the random assignment of the subjects. Now, there are some types of true experimental research designs which may be used as per the knowledge and experience of the researcher. The first and most common method is post-test only. The another method is pre-test, post-test only. And the third type is Solomon for groups. The fourth type is factorial. The fifth type is randomized block. And the next type is crossover. So these are 6 types of true experimental research designs usually used by researcher as per their knowledge and experience. Uh, Researcher who do not have suitability for the pre-test, they usually choose this post-test only, where only post-test is done, pre-test is skipped at all, because there are some situations where pre-test cannot be done and only post-test is feasible. Then another type of true experimental research design is pre-test, post-test only, where the situations are there where pre-test and post-test both are feasible. Then researcher designs the study in the way that pre-test and post-test both can be done. So how it is done is the researcher first of all through the randomization selects the subject in experimental and control group. Then he does pre-test for both the groups, and after conducting the pre-test and assessing the result of that, the researcher administer intervention or the treatment only to the experimental group. As we have already discussed that the intervention or independent variable is just for the experimental group. The control group is kept deprived of the intervention. So the control group is given only the traditional or conventional method. Now, after administering the treatment to experimental treatment to the experimental group and conventional treatment to the control group, the post-test is done. So here, after doing the post-test, the result of the pre-test and post-test are compared. And then it is usually seen that there would be some productive effect seen on the experimental group result, and control group will not have that much effect. So this way it is done. Now the another type is Solomon for groups. So here there are 4 groups taken, and how it is done is there are, instead of 1 experimental and 1 control group, there are 2 experimental and 2 control groups taken. It is again depends upon the knowledge, experience, and the suitability of the researcher. If he can take 4 groups and if he has as many as subject to include in 4 experimental and control groups. The another type of true experimental research design is factorial design, in which there are some factors considered to select the subjects and do the research. The another type of true experimental research design is randomized block design, where it is quite different from the our earlier 4 research designs of true experimental design, which we have already discussed. And the last type of true experimental research design is crossover design, where the result of the experimental and control group are usually cross-checked with each other, and this is how all the types of true experimental research designs are done. So if we see the first type of true experimental research design, it is the post-test only control design. It is composed of 2 randomly assigned groups, that is experimental and control, but neither of which is pre-tested, because its name is post-test research design only. So only post-test is done in this particular research design. For example, if we examine if CCU noise affects rapid eye movement sleep. So randomly assigned 70 women with no hearing or sleeping problems to attempt to sleep in following conditions. Noisy environments. The subjects listened to an audio tape recording of CCU sounds and the quiet environment, that is control group. Their results showed that CCU sounds can cause poorer REM sleep. The absence of a pretest was justified because participants has no sleeping problems before the experiment. We can see the diagram of this type of design. Through the random assignment, experimental and control group will be divided accordingly, and the experimental group only given the intervention decided by the researcher, and after that post-test is done. Whereas for control group, either there will not be any treatment or the conventional or traditional treatment will be administered, and after that the post-test will be done to observe the effect of this treatment. The another type of true experimental research design is pre-test, post-test only design. In this design, I'm sorry, subjects are randomly assigned to either the experimental or control group. The effect of dependent variable on both the groups is seen before the treatment. Later, the treatment is carried out on experimental group. After treatment, observation of dependent variable is made on both the groups to examine the effect of the manipulation of independent variable on variables. If we see the diagram of this type of research design, through the random assignment, the subjects will be allotted to the experimental and control group. Then pre-test will be done for both the groups. And as we all know that the treatment or intervention is always administered to the experimental group. Same way it will be done here, and the post-test will be done. And for the control group, after doing the pre-test, only the conventional or traditional treatment will be given and the post-test will be done. Now, after doing the post-test for both these groups, the comparison will be made to observe the effect of the treatment on experimental group, how it is different from the control group. Now, there is another type of true experimental research design, and that is known as Solomon 4-group design. So, as this name suggests, there are usually 4 groups taken to conduct research study, and there are 2 experimental groups and 2 control groups. This design is believed to be most prestigious experimental research design because it minimizes the threat to internal and external validity. Moreover, it allows the researcher to check that pre-test did not influence the results. If we see the diagram of this type of research design, we can see that through random assignments, subjects are divided into 4 groups: experimental group 1, control group 1, experimental group 2, and control group 2. Now, the pretest will be done for experimental group 1 and control group 1, whereas no pretest will be done for experimental group 2 and control group 2. Now, after doing the pretest for experimental and control group 1, the treatment will be administered for experimental group 1 and experimental group 2. As we all know that treatment is always administered to the experimental group only. Now, after administering treatment to these both groups, post-test will be done in all 4 groups, and the comparison will be made to see the observed effect of the treatment in experimental group, and it will be compared to the effect on control group. So definitely there will be a difference in the observed outcome of the experimental and control group. Now, the another research and another type of true experimental research design is factorial design. In this design, researcher manipulates 2 or more independent variables simultaneously to observe their effects on the dependent variable. This design is usually useful where there are more than one independent variables called factors to be tested. So here independent variables are known as factors, and more than one independent variables are taken to conduct a research. That's why it is known as factorial study or factorial design. Let's say, for example, if a researcher wants to observe the effect of two different protocols of mouth care on prevention of ventilator-associated pneumonia when performed at different frequencies in a day. This design also facilitates the testing of several hypotheses at a single time. The first number, that is known as alpha, refers to the independent variable or the type of experimental treatments, and the second number, that is beta, refers to the level of frequency of the treatment. Now we can see through this example that there are some frequencies of mouth care and there are protocols of the mouth care. Now there are three frequencies kept in this example: 4 hourly, 6 hourly, and 8 hourly. The 4 hourly frequency known as beta 1, 6 hourly frequency known as beta 2, and 8 hourly frequency known as beta 3. Whereas there are two protocols of mouth care. The first protocol is chlorhexidine mouthwash and the another protocol is saline mouthwash. The chlorhexidine mouthwash protocol known as alpha 1, whereas saline mouthwash protocol known as alpha 2. Now, how it is done is 4 hourly frequency is used for chlorhexidine mouthwash first of all. So it is alpha 1, beta 1, and the same 4 hourly frequency is used for saline mouthwash also, and that is known as alpha 2, beta 1. Similarly, 6 hourly frequency is used for both the mouthwashes. First of all, chlorhexidine mouthwash, and the second is saline mouthwash. So chlorhexidine mouthwash 6 hourly frequency will be known as alpha 1, beta 2, whereas saline mouthwash protocol with 6 hourly frequency will be known as alpha 2 and beta 2. Similarly, 8 hourly frequency for chlorhexidine mouthwash will be known as alpha 1, beta 3 here, and the saline mouthwash protocol for 8 hourly frequency will be known as alpha 2 and beta 3. Now, the another type of true experimental research design is randomized block design. Here, the control of inherent differences between experimental subjects and differences in experimental conditions is one of the difficult problems faced by the researcher in biological sciences. When there are a large number of experimental comparison groups, the randomized block design is used to bring homogeneity among selected different groups. This is a simple method to reduce the variability among the treatment groups by a more homogeneous combination of the subjects through randomized block design. Let's say, for example, if a researcher wants to examine the effects of 3 different antihypertensive drugs on patients with hypertension. In this example, to ensure the homogeneity among the subjects under treatment, researcher randomly places the subjects in homogeneous groups like patients with primary hypertension, diabetic patients with hypertension, and renal patients with hypertension. So here there are 3 categories chosen of hypertension. The first is primary hypertension. The another type of hypertension patients are with renal condition, this diabetic patients, and the another type of hypertension patients are the renal patients with hypertension. Let's see, for example, here a diagram is given where there are some types of antihypertensive drugs, and they are termed as A, B, and C. So there are 3 different types of antihypertensive drugs, and there are some blocks. So these blocks are actually divided into 3 types, and those 3 types are 3 different type of hypertensive patients. So the first type of hypertensive patients are patients with primary hypertension. The another type is patients with diabetic patients with hypertension, and the third category is renal patients with the hypertension. So when first type of antihypertensive drug, that is A, which is administered to the hypertensive patients with primary hypertension, this will be known as A and first category. And in the second block, where the hypertension patients are with diabetes, they are given the A category of drug, then this will be known as A category and second block. And similarly, when the renal patients with hypertension will be given the same A category of antihypertensive drug, this will be known as A category with the third block. Similarly, it is done with A, B, and C, all three types of category of drugs, which will be administered to all three blocks. Patients, hypertension with primary hypertension patients, uh, diabetes patients with hypertension, and renal patients with hypertension. Now, the another type is crossover design. In this design, subjects are exposed to more than one treatment, where subjects are randomly assigned to different orders of treatment. It is also known as repeat measures design. This design is more efficient in establishing the highest possible similarity among subjects exposed to different conditions, where groups compared obviously have equal distribution of characteristics. Let's say, for example, when we are comparing the effectiveness of chlorhexidine mouthwash protocol, first we administer the chlorhexidine mouthwash on group first and saline mouthwash protocol on the subject of group second. Later, the treatment is swapped. So it will be done quite opposite of what earlier we have done. So how it will be swapped is where group 1 receives saline mouth care and the group second receives chlorhexidine mouthwash. In such studies, subjects serve as their own control. Let's see the diagram for an example here. There are two groups, group first and group second, and there are two protocols of mouthwash as we have already discussed. The first mouth care protocol is chlorhexidine mouthwash, and the another mouth care protocol is saline mouthwash. So for the first time, the group first will be given chlorhexidine mouthwash, and group second will be given saline mouthwash. And when we will swap it, this treatment to the different groups, to both the groups, group first will be given saline mouthwash, and then group second will be given chlorhexidine mouthwash. Now, what are the advantages of true experimental research design? This research design are considered the most powerful design because here the first and foremost reason is researcher has entire control over extraneous variables which can not affect the result of the study. And these designs are there to establish the causal relationship between independent and dependent variable, because here the researcher can truly say that the observed effect on the dependent variable is only due to independent variable. There are no other external variables which might have affected the result of the dependent variable. Where the purpose of the research is explanation, causal relationship may be established among the variables by experimentation, especially in studies involving physical objects where the variables are more easily controlled than in human studies. In these studies, the controlled environment in which the study is conducted can yield a greater degree of purity in observation. Conditions not found in natural setting can be created in experimental setting where the independent variable is manipulated by the investigator. So these all were the advantages of the true experimental research design. Thank you. Thank you so much.